So we were looking at the indefinite integration of a trigonometric function. So within the indefinite integration of a trigonometric function, we have looked at the trigonometric function where t is a trigonometric function. We have also looked at a trigonometric function of square. Now we'll look at the trigonometric function of a cube. Okay, today we'll look at the integration of a cube of a trigonometric function, that is sin cube x dx, cos cube x dx, tan cube x dx, cosec cube x dx, sec cube x dx, and cot cube x dx. Okay, we have already done the simple trigonometric function, we have already done the square of a trigonometric function. Now we'll see the cube of a trigonometric function. Okay, so we'll solve one by one. Let's go with the sine function. So sine of cube x dx. So there are many ways to solve sine cube x. We have to anyhow convert into something linear. Okay, linear form. So cubic into linear. So we have a identity, trigonometric identity, that says that sine 3x is equal to 3 sin x minus 4 sine cube x. That simply means that sine cube x will be written as 3 sin x minus sine 3x upon 4. Okay, so that simply means that we can write the sine cube x dx as integration of a 3 sin x minus sine 3x upon 4 dx. So we can break it like this. It will be 3 by 4 sin x dx minus 1 by 4 sin 3x dx. Okay, we just 3 sin x upon 4 and minus sin 3x upon 4, we break like this. So now its integration is simple. It's a 3 by 4 integration of a sin x is minus cos x, and minus 1 by 4 integration of a sin 3x will be minus cos of 3x divided by 3. We have done in the previous also that the coefficient of x is 3, so that will be divided as well, plus constant. So that means it will be, so the integration of a, now we can write the integration of a sin 3x dx is minus 3 by 4 cos x plus cos of 3x upon 12 plus constant. So this is the integration of a sin cube x. Okay, now let's see the integration of a cos cube x. Again we have a trigonometric identity. So using the, we'll use the trigonometric identity. Okay, using trigonometric identity. So the trigonometric identity says that cos of 3x is equal to 4 of cos of cube x minus 3 cos x. Okay, so that convert into the cos of cube x is 3 cos x plus cos of 3x upon 4. So that means we can write the cos of cube x dx as integration of 3 cos x plus cos of cube x upon 4 dx. So we can break it like this: 3 by 4 cos x dx plus 1 by 4 cos 3x dx. That simply means 3 by 4 cos, integration of cos x is sin x plus 1 by 4 integration of cos 3x is sin 3x upon 3 plus constant. So integration of a cos 3x dx will be 3 by 4 sin x plus 1 by 12 sin 3x plus constant. So this is the integration of a cos cube x. Okay, so we have done the sine cube x, we have done the cos cube x. Let's see the tan. Third is the tan of cube x. Okay, so there is no direct identity to convert a cubic into linear, but we can use a simple manipulation. So we can write like this. We know that the tan square x is sec square x minus 1. So 1 plus tan square x is equal to sec square x, or tan square x is equal to sec square x minus 1. So we can write this tan cube x as a tan x into tan square x dx. So that convert into tan x and sec square x minus 1 dx. Now why it is helpful? So we break it, so we'll understand what it is. It will be split like this: tan x sec square x minus dx minus tan x dx. So we know the integration of tan x, but we don't know the integration of this term. Just clearly look at this term. So if you want to integrate this term, if I assume tan x is equal to t, so the differentiation of tan x is sec square x dx is equal to dt. So that convert into t dt. Okay, and this part is already tan x dx. So the integration of this part is t square by 2, and integration of tan x, we know that is we have done previous ln mod of sec x plus constant. Now here we'll substitute the value of t square. T square means tan square x upon 2 minus ln sec x plus constant. So now we can write the integration of tan cube x is equal to tan square x upon 2 minus ln mod of sec x plus constant. So this is the integration of tan cube x. Okay. Now let's talk about the integration of this is simple. So we'll take first cot cube x dx. Here also we can use the trigonometric identity that cot square x is equal to cosec square x minus 1. So here we'll say cot x will be cot x cosec square x minus 1 dx. So it will be split like this: cot of x cosec square x dx minus cot x dx. Now again this is can be easily integrated, because this we know that directly identity or directly formula we have done in the previous videos. Here we assume the cot x is equals to t. So differentiation is minus cosec square x dx is equals to dt. So this part will be cot x is t and cos square x is minus dt, and this minus cot x dx. So that will be minus t dt, and this part we know the integration of cot x is ln mod of sin x. So this integration is minus t square by 2, and this we already know is ln mod of sin x plus constant. So if you substitute the value, we can say the integration of cot cube x dx is equal to integration minus t means cot x square upon 2 minus ln mod of sin x plus constant. So this is the integration of cot cube x function. Okay, minus cot square x upon 2 minus ln mod of sin x plus constant. Okay, let's talk about the integration of sec cube x dx. Now this is not very easy to integrate this term. We have to use, so here we have to use integration by parts. Okay, So how? So we'll break like this: sec x sec square x dx. So one of the function we take as the first and the second. So let's say I take sec x as the first and the second. Okay. So if we want to integrate, we know that integration by part. So integration of first function into second function dx, one of the function will be integrated and one of the function will be differentiated. So we know that first function will be, one of the function will be integrated. So let's say integration by parts formula is function remains as such, other function is integrated, then minus total integration of one function is differentiated and one function is integrated, and overall this function is integrated. Okay, this is how we write the integration by part. Or we know that so f into g dx, if you want to integrate, we write one of the function as such and one function is integrated minus total one function is differentiated and the one function is integrated, and overall this function is integrated. So this is how we write the integration by parts. So we'll use the integration by parts here. One of the functions is integrated, so we use the second function, the sec square function is integrated. Why? It is easy to integrate. And one of the functions is differentiated. So sec x is easy to, so any function can be differentiated, there is no issue in differentiation. But it is easy to integrate sec square x, that's why we use sec square x as second function, which is basically integrated. So sec x is differentiated, so sec square x is integrated and sec x is differentiated. So the function will be something like this. So let's start with the sec x sec square x dx. Sec x remains same, but sec square x is integrated. Integration of a sec square x is tan x. We know that integration of a, so basically this function is integrated. So we know that the integration of a sec square x dx is tan x. So that's why sec square x function is integrated, that becomes tan x, and overall minus sec x is differentiated. If we differentiate sec x, that becomes sec x tan x. We know that the differentiation of a sec x is sec x tan x. So that's why the differentiation of a sec x is sec x tan x, and the function which is integrated is tan x, and this whole is integrated. Okay, the whole function is integrated. Okay, so basically we started with the sec cube x dx, and that converted, that is at some part sec x tan x minus, this is again sec x tan square x dx. This is how we got it. Now it will become sec x tan x, no issue. But if we want to integrate, we observe that this, it will be little bit simplify if I write tan square x is what? Sec square x minus 1 dx. So that will be sec x tan x sec cube x minus sec x dx. So let's split it. It will be sec x tan x, and if you split, that becomes integration of a sec cube x dx, and this minus integration of a sec x dx, and just open it, will get sec x tan x minus sec cube x dx, and this minus plus sec x dx. Okay, and you observe that this particular sec cube x, this is same as this function. So this is sec cube x dx. So they are same, sec cube x dx and this. So this will be taken towards the left hand side, and that becomes 2 sec cube x dx is equal to, that is sec x tan x plus integration of sec x. We know the integration of sec x is, we already done, that is ln mod of sec x plus tan x plus constant. So that means we can say the integration of a sec cube x dx is sec x 10x upon 2 plus ln mod of sec x plus 10x upon 2 plus constant. So that is the integration of a sec function. Okay, sec x 10x upon 2 plus ln sec x plus 10x by 2 plus constant. Okay, now similarly we can integrate the similar approach for the cosec cube x dx. Okay, so that's similar to the sec cube x. We'll write the cosec cube x like this. So basically what it means is that just like we have done here integration by parts, so using sec x and sec square x, here also we'll use integration by parts, which one function is cosec x and other function is cosec square x dx. So we know that the integration of, since we know that integration of a cosec square x dx is minus cot x, so it's integrable function. We use cosec cube x as an integrable function, and the differentiation of a cosec x is minus cosec x cot x. So we use cos x as function as a differentiable function. So we'll use the integration by parts. Using integration by parts, we can say that cosec square x dx. So since we are using integration by parts, we know that if we want to integrate first function, second function, so first function as such, the integrable function is this minus total integration of first function differentiation, and this second function which is integrated is second dx, and this overall is integrated. So we use the same here. So cosec x which is to be differentiated is remain same, and cosec square x which is integrated is minus, we know that integration is minus cot x. So that becomes minus cot x minus overall integration. So the differentiation of cosec is cosec x cot x, and then integration of so minus cot x dx. Okay, so that simplifies, let's say I write again this part. So that becomes cosec cube x dx is equals to minus cosec x cot x, and that is let's say it is minus, and this overall minus plus, so that becomes cosec x cot square x dx. This is we obtain. Now again this turn out to be, so this is cosec x cot x minus, now in place of cot square x, as we did in integration of sec cube x, here also we'll replace cot square x by cosec square x minus 1 dx. Okay, because cos square x is cosec square minus 1. That becomes minus cosec x cot x minus cosec cube x minus cosec x dx. That is cosec x cot x, and now we'll break it, so it becomes what? Cosec cube x dx and minus plus cosec x dx. So again this part will go to the left hand side, and what is left hand side? Left hand side is cosec cube x dx. We'll take left hand side, that becomes 2 times, so this goes to here, so that becomes 2 times cosec cube x dx, and rest of part is cosec x cot x plus integration of cosec x dx. So that becomes 2 times integration of cosec cube x dx is equal to minus cosec x cot x plus, and integration of cosec x dx is, we already done, is ln mod of one of the integration is 10x by 2 also. Okay, so you can use any, because in the previous video I have shown the integration of cosec square 10x by 2 also. So one of the integration 10x by 2, it's simple, so I am using 10x by 2. plus constant. So the integration of a cosec cube x dx is equal to minus cosec x cot x upon 2 plus ln tan x by 2 upon 2 plus some constant. So this is the integration of a cosec cube x. Achha, by the way, you should know that there are, if I see integration of a cosec x dx, there so it's not just one function, there may be, so I have used one function. The integration, other possibilities, one is ln mod of cosec x minus cot x plus constant, other is ln mod of tan x by 2 plus constant. So there are basically two types of integration is used here broadly. So here I have used tan x by 2, ln tan x by 2. You can use the ln cosec x minus cot x also. So depending on your answer will different, but essentially they are same. We have done the previous videos where we have converted from ln cosec x minus cot x to ln tan x by 2. So this completes the integration of a cubic function. Okay.